In the previous lectures, we have understood the crucial features of BERT. In this lecture, I would like to tell a few words about an extremely crucial token in this architecture, the so-called CLS, that stands for classification. In this lecture, we will understand these special tokens, and in the coming lectures, when we will talk about pre-training the BERT architecture and fine-tuning the architecture, we will understand exactly how to use these tokens. But somewhere we have to start understanding the architecture. So if you do not understand anything at the moment, don't worry. I will make sure that we understand every single part of the architecture step by step. And finally, I'm sure that you will understand the big picture, what's happening exactly under the hood. So this CLS is a special token in the input sequence that represents the entire input sequence. It is a special token added at the beginning of the input sequence to provide a summary of the entire sequence meaning. First of all, let's assume that we have an input sequence. The cat sat on the mat. So this is the input sequence. Of course, there are independent tokens such as cat, and so on. And then we append a special token as the first token in the input sequence. This is the CLS token that stands for classification. By the way, there are other special tokens as well, such as the separator token. If we use just a single input sequence, then there is no point in using the separator, but anyways, usually we append the separator to the end of the input sequence. We will come to the conclusion that it is crucial when we have multiple sequences as the input. So for example, if we concatenate multiple sequences, then we end up with a single sequence where the separator separates the sequences accordingly. So this is why this separator can prove to be quite useful. But if we are dealing with just a single sequence, we have a classification token at the beginning and we have the separator token at the end. And of course, every single token will have a word embedding representation, exactly as we have discussed in the previous chapter. So the token the can be represented with this word embedding vector. Then we have another word in the input sequence, for example bank. The bank can be represented with this one-dimensional vector, that is another word embedding vector, and so on. So every single token has a vector representation. This is exactly the same here. And what's crucial that the classification token has a word embedding representation and the separator token has a vector representation as well. But here is the crucial difference. Every single word vector represents a single token in the high-dimensional vector space. On the other hand, the classification token represents the meaning of the entire sequence, which means that this classification token goes through all transformer layers along with the other tokens in the sequence. Each layer updates the token's representation by incorporating contextual information from the entire input. And after all encoder layers, the hidden state of the classification token, so essentially the word embedding vector, is used as the final representation of the entire sequence. This vector representation of the classification token can be parsed into the fully connected neural network, and this is how we will achieve sentiment analysis or text classification. Okay, so during the attention operation, we will calculate this matrix containing every single token of the input sequence, and we will include the classification token as well. And what does it mean? That after the attention operations, the classification token, which is essentially the first row of the matrix, by the way, in some articles, we are dealing with a column representation, but of course, course, in scientific articles, usually we are dealing with rows and not columns. So the first row represents the values in the classification token related word embedding. And this is extremely crucial. I don't want to repeat myself over and over again. But for example, the bank related word embedding represents the meaning of the word bank. On the other hand, the word embedding associated with the classification token represents the meaning of the input sequence, which means that it represents the meaning of every single word in the sequence. So essentially, instead of dealing with just a single word, it is dealing with the entire sequence. So it represents the semantic meaning of the entire sequence. And of course, as you may guess, because it includes all the information for the input sequence, this is why this is going to be crucial when we want to achieve some task such as sentiment analysis or text classification, because a single vector contains the meaning of multiple words. So we can come to the conclusion that in the high-dimensional vector space for the word embeddings, we have the words that are present in the sequences, so essentially in the training dataset, and we will have a vector for this classification token, but this vector doesn't represent a single word. It represents an entire sequence containing multiple words. Okay, so in the coming lectures, we are going to talk about how to pre-train the BERT architecture.